Hi there, General Maths students. In this video, we're going to discuss float. This carries on from the previous video on critical path analysis. And within any project where we have critical path analysis, there are some activities that are not on the critical path which have what we call slack. That means they don't need to be started and finished at exactly the specified time. They could be delayed or take a little bit longer and not hold up the overall project. I want you to focus on the second equation here, not the first one. We're going to be using this equation in this video, and that involves late finishing time, LFT, which if we look at a particular activity like this one down on the bottom right here with activity A, that is the end of activity A, the bottom of the house is that one, right? The latest finishing time. So we see here it's 50 in the equation. And then we subtract from that the activity duration, so in this case 5. And then we subtract the earliest finishing time, which is the top of the previous house, or the starting house, the house at the beginning of the activity at the top. So we've got the end house and the starting house. It's the bottom of the end house minus the activity minus the top of the starting house. Let's do a couple of examples. So you might feel confident enough to pause the video at this stage and try these on your own. Then I'll have a go, or maybe watch me do the first one and then try after that. So see what you want to do, then I'll try it. So this first one, it's the bottom of the house at the end, subtract the activity time and subtract the top of the house at the start. So in this case we've got 75, take 5, take 50, which is 20. So the float for that activity is 20. Okay, you might want to pause now and try the next two, then I'll have a go at it. So for this one, 87, take 16, take 20. Take that. And what does that give us? 51. And the last one, 55, take 15, take 30. And that is, in fact, 0, isn't it? That would mean that activity is on the critical path. So it cannot be delayed without delaying the overall project. And you can tell that an activity is on the critical path because the top and the bottom numbers match. So those ones from critical path analysis, those must be on the critical path. Okay, so whipping ahead here is a graph for going camping. We constructed this earlier, and you might want to go back and actually do this on your own. So I'll get off that. You might want to go to that camping one and do all the stuff that I've filled in so far and see if you can do it on your own. Then I'll go back to that slide, and it's mostly filled in. I'm just going to do the last few on that one, and then you can check your answers against mine. So if you want to try that on your own, it's example 3.5. And as it says in the description for the video, example 3.5 is on page 22. So I've done most of it. You can go and try it on your own. Then I'll do it. Righto. So here is this example 3.5. I've done the critical path analysis myself, and I suppose I could show the critical path here. It's not really, it is part of this. So remember, we're identifying the ones that have the same number at the top and the bottom. So there's our critical path, I suppose. Overall, the completion time is 52 minutes. And the critical path is ADF. Okay, Now I've gone ahead and calculated earliest start time and late finishing time, latest finishing time, and the float for each of these. You might have done them by now, or you want to just check your answers against these. I'm going to see now, you might want to pause the video, check these and see if you understand how I got them. Then I'm going to do the rest with G and calculate the float for G, H and I. So you could pause now and fill in the rest of this table based on what's there so far. Okay, so remember, for instance, activity A, it's the bottom of the first table, the end table minus that activity duration minus the top of the table at the beginning. So for A, we've got 15, take 0, which gives 0. A is on the critical path, so a float of 0. So that's how we work them out, just like before. Now, for G, if we look at activity G, the first number, 52. So that is our latest finishing time. And the number at the beginning is 5. So that's our earliest start time. So for this one, latest finishing time being 52 for G, take the activity time, 10, take 5. And that gives us a float of 37 minutes. So tables and chairs, that can be delayed for up to 37 minutes without without delaying the setting up of the camp overall. Okay, for H, here's activity H down here. 32 is our latest finishing time. And we have an earliest start time of 5. So the float here, 32, take 25 for the activity time, take 5 for the earliest start time, which gives us 2 for our float. And finally, I, activity I, here it is here, 52 and 30. So the float is 52, take the activity time of 20, take 30, which gives us 2, just like for H. So it's exactly the same as before. Normally we're going to use these, we'll be calculating float in these situations where we've done some critical path analysis. So we just use the houses and the activity just the same as in the previous examples. Okay everyone, so go ahead and try the examples that are in the questions that are in the description for the video.